Thank you for the introduction. Okay. Today, in my talk, I'm going to show how artificial landmarks can improve spatial memory development and provide efficient linear document revisitation. So first, let us see what is linear document and how we interact with the linear document systems. So documents whose contents are sequential are generally known as linear documents, such as PDF and videos. Popular linear documents, such as PDF and videos, use one-dimensional widgets for navigation, so which are known as sliders and scrollbars. We're all familiar with this kind of interfaces. So these linear controls provide an abstract representation of the whole document in the one-dimensional control widgets. So I'm saying it one-dimensional control widgets because it's such using either y-axis or the x-axis. So in this kind of interfaces, the control actually map each location of the document to a specific location on the scroll bar or on the slider. And by clicking on the respective locations of the scroll bar or the slider, it's possible to go back to a specific location of the video or a PDF. However, all the location of the controllers look same. So it can be difficult to develop spatial knowledge of the document and eventually difficult to navigate back to those locations that the user has already visited. So which brings us to the problem that we have focused in this work, and that is, it's difficult to learn and revisit linear document locations efficiently and accurately. So let us see how we remember different locations in real life. We use different landmarks to remember different locations, and we actually refer to those locations to know the places nearby. For example, using the Tower Bridge of London, we can remember the nearby places such as the Tower of London or the Elizabeth Tower, which is known as Big Ben. So landmarks are also useful in computer interfaces. Recently, we introduced an artificial landmark system for spatially stable desktop interfaces, and with our work, we showed color blocks in the grid, and the background image of the grid can work as powerful landmarks. And those landmarks actually help users to learn and remember command locations more conveniently. So we propose to use artificial landmarks in linear document controllers to overcome the location revisitation problem. So we augmented two different linear controllers, media player and PDF viewers, with artificial landmarks. First, the media players. We augmented the horizontal one-dimensional slider controller of a media player with two types of landmarks. The first one is abstract symbol, as you can see in the bottom, which are random, and those icons had no connection with the content. So we use, and in the other one, we used few scenes as thumbnails from the video, which were extracted from the actual content, as you can see in the bottom of the bottom part of the slider. So those thumbnails were taken actually from the video. And the intention was that the landmarks will provide clear referencing point to the users so that they can remember this location and directly go to those positions simply by clicking on the locations. As you can see in the bottom part, the user is clicking in the location and simply going to the direct location. And similar to the media players, we augmented the PDF viewers with artificial landmarks. The only difference is that previously it was in the horizontal case, and now it's in the vertical case. So we have used similar abstract icons and thumbnails as landmarks. And the interaction was actually similar, and this time it was the PDF viewer only. So by clicking on those locations, they can actually directly go to the direct pages. To test the effects of these landmarks on revisitation performance, we conducted a study where we compared these interfaces. So in our experiment, there are three types of interface. First, the standard interface. So these are the standard interfaces that will look like. These unadorned one-dimensional controller-based media players and PDF viewers provided the baseline condition of our experiment. As you can see, nothing was there in the controller part. Second, the icon interface with abstract icons. So we used random monochrome icons as artificial landmarks in the one-dimensional controller part of these interfaces. The icons were totally random, and they had no connection with the contents except their relative positions on the scroll bar. So we used around 30 icons 30 icons as landmarks in the systems. So in media player there are 34, and in PDF viewer there are 30 icons just to accommodate the space. And third, the thumbnail condition. So we extracted few scenes from the contents. Actually, we extracted 11 thumbnails from the video and pages of the PDF to create the thumbnails, which are used as landmarks. And the thumbnails were selected in a way that it approximately covered the whole space of the controller. So now the study design. So in our experiment, we actually recruited 30 participants. And the task involved in the study was browsing through a 42-page long PDF document and watching a 2-minute long video. Later, they were asked to revisit different locations of the video and the PDF viewer using our systems. So in our experiment, we used a mixed within and between participant study design. But there are 3 groups in our experiment, and each of the groups, they only used either one PDF and one media player. So we logged times, errors, and other relevant information during the study. Now, the results. So we compared the results of media player and the PDF viewer separately, just to make it sure. First, I'm going to talk about the completion time. As you can see, the trial completion time decreased over time according to the blocks for the 3 conditions. And it was true for both media player and PDF viewers. For the media player, in the left-hand side, we see that both landmark conditions performed better than the non-landmark condition, and it was significantly better. And similar pattern was seen in PDF viewer also. Overall, the completion time analysis, you can see that because of the artificial landmarks, the icon and thumbnail condition performed better, and they provided significant revisitation facilities. And among the 8 target locations for the thumbnail condition for both interfaces, like the media player and the PDF viewer, few targets were exactly on the landmark, and some of the icons were near the landmark, as you can see in the bottom image. So we analyzed those clicking performances based on the proximity to their landmark. And for the media player, we can see that on landmark locations were faster than the near landmark locations, and which makes sense actually. But the difference was not significant for media player. However, for PDF viewer, on landmark locations were significantly faster than the near landmark locations. So in general, we can say that landmarks are beneficial for revisitations. We analyzed the errors of the revisitation, and by errors, actually, we are mentioning the incorrect revisitations. So our analysis showed that overall errors for both media players and PDF viewers were less. And for media player, we can see that thumbnail condition had the lowest number of errors compared to the other 2 conditions, and the difference was significant. And for the PDF viewer, similar trend was visible, and thumbnail had the significantly low error rates than the other 2 conditions. Now, analysis by target. According to the serial position effect, people best remember first and last item from a series of lists, so which is also known as the primacy and recency effect. From the primacy effect, it means that people can remember the first item very clearly, and from the recency effect, it means that if we see a lot of items, we can remember the last item very clearly. But there's a problem in the middle. So that's what we actually focused in our experiment. So we analyzed the performance by targets for both media players and PDF viewers to see the effect. So here you can see all the 8 targets that were used in our experiment. First, I'm going to talk about the media players. So for completion time, here actually we are showing errors and completion at the same time, considered on the dotted line first. Those are the times. So we found significant difference among 3 conditions and target locations. And overall, thumbnail performed better. However, in case of target 5 and target 7, which are you can see in the middle, thumbnail condition was significantly better than the other 2 conditions. For errors, again, we found significant difference among 3 conditions. Now we can consider on the lines and the bars over here. Though overall thumbnail performed better, thumbnail was significantly less erroneous at location 2, 4, 5, 6, and 7. Here you can see at the middle position, people are easily remembering the locations. We again analyzed the results for PDF viewer, and we found similar results for completion time, and the difference was significant among 3 conditions and among 8 targets. We also found both landmark conditions were significantly faster, especially in the middle positions, like for 2, 5, and 4 and 5, the difference was significant. If you can see it here, like they are taking more time, and the error was really high in case of standards. For error, we found both landmark conditions were significantly less erroneous in the middle targets, especially from 2 to 7. So from these results, we can see that landmarks can overcome the serial position effect. So participants actually provided subjective response, which we analyzed separately. From the NASA TLX workload for the media player revealed that both landmark conditions performed better than the standard condition. And for mental, physical, temporal, and frustration measure, the difference was significant. Participants, for PDF viewers, we found similar pattern, except for physical and effort. And we got significant differences for all the other conditions. At the end of the study, participants provided their preferences between 2 interfaces, and results showed that landmark conditions was preferred, like compared to the standard icon, standard. And here, if we compare between these 2, then thumbnail was preferred. However, between these 2 landmark conditions, thumbnails was highly preferred. So as a summary of our study, we can say that both thumbnails and icons provided faster revisitation facilities than the standard no landmark conditions. Thumbnail provided better and accurate landmarks between 2 landmark conditions because they actually provided clear referencing point. And finally, thumbnail was mostly preferred. Okay, now the future work. So in our experiment, we only considered a 42-page long document and a 2-minute long video. However, for a long document, such as a PDF containing hundreds of pages, accurate revisitation might be a challenge. Because a slight movement in the slider, it can represent a lot of pages ahead. So in such cases, we can use 2 columns of artificial landmarks, just like this one, so which might provide better revisitation facilities. We also found that because of the clear representation of contents, the thumbnail provided better revisitations. But it is not possible to put a lot of thumbnails in the scroll bar or in the slider because of the space issue. However, we can put a lot of icons in the system. But the icons that we have used in our system, they had no connection with the contents. So instead of using random abstract icon, we can use related icons in the system. Just as you can see in the example, for the camera scene, we can use a symbol of a camera in the scroll bar so that it can actually refer to that location. So we would like to explore this idea in future. So from my talk, what I want you to take away, that is artificial landmarks can improve the revisitation performance of linear documents. Thank you, and that's all. If you have any questions, I'd like to answer.
Thank you very much. There is time for questions.
Thank you for your presentation. My name is Nicholas Katsakis from the University of Hamburg. I'm wondering how this landmark technique would work for documents that continue to load over time. So you have sometimes a web page and the next contents load and that makes the scroll bar change size. Have you guys explored how this would?
So far we have not explored that idea because in our experiment we have considered only a fixed length document. But still, yeah, this can be a good area to explore in future. As I have said that in future we would like to consider a long document which has at least 1,000 of pages. So we would like to explore that idea. So right now I have no clear answer for that.
Thank you.
Hello, thank you for your presentation. I wanted to ask about the number of the thumbnails and the icons.
Yeah.
If they were of the same number, and also for the size, because it seems like the thumbnails were bigger, so easier to remember as well. And also, one extra quick question, if they were selected based on specific scenes or the emotional stimulation, just asking, thank you.
Okay, thank you for the question. Just to clear one thing, like in our two systems, all the thumbnails had same size. So there's no difference. Maybe because of the image over here, you got the impression that, but it was actually the same size. And for the number of icons and the thumbnails, so we wanted to use the whole space. That's why we used, in the media player, we used 34 icons. And in the PDF viewer, we used 30 icons, just to cover the whole space. And we adjusted the size, like, as far I remember right now, the size of the icon was 64 pixels, like 64 by 64, the icon. And what was the third question? Actually, I forgot it. Can you just repeat it, the third one? The selection of the... Okay, yeah, that's the interesting thing. In our experiment, we tried to cover the whole space. So that's why you have selected the thumbnails with, in a way so that it covered the whole space. But we tried to, like if you see in the thumbnails, let me just show you the thumbnail here. Just a little bit. Okay. So you can see in the thumbnail over here. So we actually manually selected the scenes. Like as in the video, the scenes are actually continuous. So if you select this scene, you can understand. Okay, so if the later, at least the scenes that are going to take place in the next 1 or let's say 30 seconds, they're probably similar. So that's why we picked just one scene for this whole range. So in this way, we actually end up selecting these 11 thumbnails. And you can see the paper, so there are more description about it. And for the PDF, we selected, you can see that they are clearly, they have almost similar space. So we did not go for that one for our PDF viewers, so we just selected so that in a way, so that it can cover the whole space. I guess that's answered your question.
Okay, I have a question.
Yeah.
So you're just, I guess, tested in a desktop environment. So what about the mobile? And because the screen size is different, so we have the problem of the screen size and also the finger size. So what happened there?
Okay. I guess the answer is similar to the first one, because in our study, we have used a 24-inch monitor, but if you consider the cell phone or even a tablet, obviously space is an issue. And there is a common problem called fat finger problem. So we are aware of this thing, but we have not tested in a smaller form factor. Maybe we have to change the design, and obviously know that like if we consider a small window, obviously we cannot accommodate this much of icons. So maybe we have to use different kind of landmarks. Maybe we can use color. We can use icons in smaller scale also, but we cannot use the thumbnail. From my experience and from our results, we can say that.
We have time for another question. Okay, I have a question.
Yeah.
Do you have in mind to change the possibility to have the different time frames? So instead of dividing the video according to the number of icons, to use a larger time lapse for idle time, for example, we are working in maintenance, and so there are long videos and there are huge segments with boring or time where the video is stuck to some still image. So if you can improve this system using different time frames.
Yeah. Thanks for the question. There's also an interesting area to look at. Right now, we have manually selected the icons and thumbnails, but there are some works that are mentioned in the related work section of this paper. If we can make it automatic, like we can use some machine learning approach or something like that, then we can actually generate icons or thumbnails based on the situations that you have mentioned. That if you are watching a surveillance video, and let's say you are watching a parking lot, so nothing is happening for at least 2 or 3 hours. So we can use something like, we can use a static option for that one. So it can be possible to do, like if we use machine learning or that kind of approach. But right now, this is just static.